Manohar from the EL6303 probability class. Today I'm going to explain the problem f of x comma y equal to a y squared. The limits are 0 less than y less than mod x less than 1 and it's 0 otherwise. Now we are taking into consideration that f of x comma y is a valid joint density function. We have to find out the value of a. For finding out the value of a, we can use this formula: minus infinity to infinity minus infinity to infinity fxy of x comma y dx dy equal to 1. The range of x is from minus 1 less than x less than 1, and the range of y is from 0 less than y less than mod x. So minus 1 to 1, 0 to mod x, a y squared dy dx equal to 1. Now we can take a outside, minus 1 to 1 dx into 0 to mod x y squared dy equal to 1. So a minus 1 to 1 dx into y cube by 3 0 to mod x equal to 1. So we can take this 3 outside, so it becomes a by 3 minus 1 to 1 dx to mod x the whole cube equal to 1. So now we have to integrate this, so since it's the modulus of x the whole cube, we can split it up into two parts for the real part and the imaginary part. So a by 3 minus 1 to 0 minus x cube dx plus 0 to 1 x cube dx equal to 1, and a by 3 minus x power 4 by 4 minus 1 to 0 plus x power 4 by 4 0 to 1 equal to 1. So a by 3 into, this becomes 0 by 4 minus of minus 1 by 4 plus 1 by 4 equal to 1. So a by 3 into 1 by 4 plus 1 by 4 equal to 1. So a by 3 into 1 by 2 equal to 1. Therefore a equal to 6. We have to do the second subdivision of this problem, which is find and draw the marginal density function f of x. So fx of x is given by minus infinity to infinity fxy of x comma y dy. Here, since we are taking dy, the limits of y should be taken over here. Therefore 0 to mod x 6y squared dy. So this becomes 6 into y cube by 3 0 to mod x. Of course this 3 and this 6 get cancelled, so it becomes 2. So it becomes 2 into mod x the whole cube. So 2 mod x the whole cube. This is the function for fx of x, and now we are going to draw the marginal density function. So it's x fx of x, and it's 0 1 2 minus 1 minus 2. Now for x equal to 0, fx of x is equal to 0. Now for x equal to 1, fx of x is equal to 2, and for x equal to 2, f of x is equals to 16. So the graph just goes like this. Yeah. Now we proceed to the third subdivision. Find and draw the marginal density function of f of y. So fy of y equal to minus infinity to infinity fxy of x comma y dx. Here the limits of y ranges from 0 less than y less than mod x. So y ranges from so the limit of y ranges from minus 1 to minus y and y to 1. Therefore, minus 1 to minus y, 6y squared dx plus y to 1, 6y squared dx. So this is 6y squared into x minus 1 to minus y plus 6y squared into x. This is y to 1. Now 6y squared into minus y plus 1 plus 6y squared into here it's minus 1, yeah, 1 minus y. So therefore it's 6y minus 6y cube plus 6y squared plus 6y squared minus 6y cube. So this is minus 12y cube plus 12y squared. So we can take 12y squared as common. So this gives us to minus y plus 1. Now this is 12y squared of 1 minus y. Yeah. Now to plot the marginal density function graph of the above function, now if we substitute y equal to 0, we get 12y. Y equal to 0, we get fy of y equal to 0. And when we substitute y equal to 1, we get fy of y equal to 0. So the graph proceeds like this. Here this is y, this is fy of y. Proceed over to the fourth subdivision. Find and draw the conditional density function of f of y given x. So the f of y given x is given by fxy of x comma y by fx of x. So this is 6y squared, and fx of x we got it as 2 into modulus of x the whole cube, which is 3y squared by 2 mod x, 3y squared by mod x the whole cube. Now to plot the graph for the conditional density function of f of y given x. Now when x equal to 0, the graph proceeds to infinity. Now when y equal to 0, the graph is 0. So the graph goes like this. So this is x, this is f of y given x. Next we proceed to the fifth subdivision. Find and draw the conditional density function f of x given y. So f of x given y equal to fxy of x comma y by f of y. So this is given by 6y squared by 12 into y squared minus y cubed. So this goes 2 times, equals to y squared by 2 into, taking y squared common, so we get 1 minus y. So y squared cancel, which gives rise to 1 by 2 into 1 minus y. The graph of f of x given y is given by f of x given y, f of x, so limit 1, limit is minus 1, here it's minus y, it's y, and if when we substitute y equal to 1 here, the graph tends to infinity, so it goes over here and it goes over here. So there is no values between minus 1 and 1, and only greater than 1 and less than minus 1. So this is the graph of f of x given y. And now for the last subdivision, we have to find the mean values, that is e of x, e of y, and e of x y, e of y given x and e of x given y. So now e of x is equals to minus infinity to infinity x fx of x dx. So the value of x ranges from minus 1 to 1, x 2 mod x the whole cube dx. So 2 minus 1 to 1, x into mod x the whole cube dx. This given function is an odd function, so integrating it between minus 1 and 1 will obviously give the answer 0. So e of x is equals to 0. Now you have to find the next thing, e of y. E of y equal to minus infinity to infinity y fy of y dy. So y ranges from 0 to 1 y into 12 into y squared minus y cube dy. So 12 comes outside, 0 to 1 y cube minus y power 4 dy. So 12 into y power 4 by 4 minus y power 5 by 5, 0 to 1. So 12 into 1 by 4 minus 1 by 5. So 12 into 1 by 20. So which is 12 by 20. So which is 6 by 10, which is equals to 3 by 5. Now see E of xy. E of xy equals to minus infinity to infinity xy fxy of x comma y dx dy. The expected value of x comma y is given by double integral 0 to 1 0 to minus x xy into 6y squared dy dx plus this is minus 1 to 0 and this is 0 to 1 and this is 0 to x xy 6y squared dy dx. So this is minus 1 to 0 x dx, then the integral 0 to minus x y cube dy plus 0 to 1 x dx. So this is 0 to x y cube dy. So this is minus 1 to 0 x dx and y power 4 by 4 0 to minus x plus 0 to 1 x dx y power 4 by 4 0 to x. And now minus 1 to 0 x dx into x power 4 by 4 plus 0 to 1 x dx into x power 4 by 4. So the 4 comes out, it is 1 by 4 and x into x power 4 gives us x power 5. So x power 5 dx integral minus 1 to 0 x power 5 dx plus 1 by 4 integral 0 to 1 x power 5 dx. So this is 1 by 4 x power 6 by 6 minus 1 to 0 plus 1 by 4 x power 6 by 6 0 to 1. So this becomes 1 by 4 0 plus 1 by 6 plus 1 by 4 into 1 by 6. So this is a minus. So this becomes 1 by 4 into minus 1 by 6 plus 1 by 4 into 1 by 6, which eventually turns into 0. Therefore, E of xy equal to 0 and E of x equal to 0 and E of y equal to 3 by 5. So E of x comma y xy equal to E of x into E of y equal to 0. So x and y are uncorrelated functions. And for the next subdivision, E of y given x, this is given by minus infinity to infinity y f of y given x dy. So this ranges from the limit 0 to mod x y into 3y squared by mod x the whole cube dy. So by taking the unwanted terms outside, we get 3 by mod x cube, so 0 to mod x y cube dy. So y cube dy, so we get 3 by mod x the whole cubed into y power 4 by 4, which of mod x 0. So 3 by mod x the whole cubed into mod x power 4 by 4. So mod x cube and mod x power 4 gets cancelled, which results in 3 mod x by 4. And for the last subdivision, e of x given y, which is minus infinity to infinity x f of x given y dx. So which results in minus 1 to minus y to minus 1 x into 1 by 2 into 1 minus y dx plus y to 1 x into 1 by 2 into 1 minus y dx. So by taking the unwanted terms outside, we take 1 by 2 into 1 minus y, we get x dx of limit minus 1 to minus y to minus 1 plus 1 by 2 into 1 minus y integral y to 1 x dx. So this is 1 by 2 into 1 minus y x squared by 2 minus y to minus 1 plus 1 by 2 into 1 minus y, this is x squared by 2 y to 1. So this gives to 1 by 2 into 1 minus y, 1 by 2 minus of y squared by 2 plus 1 by 2 into 1 minus y, 1 by 2 minus y squared by 2. So this goes to 1 by 2 into 1 minus y, 1 by 2 minus y squared by 2 plus 1 by 2 into 1 minus y, 1 by 2 minus y squared by 2. So this is to 2 into 1 by 2 into 1 minus y into 1 by 2 minus y squared by 2. So this is 2 into 1 by 2 into 1 minus y, 1 minus y squared by 2. So this 2 and this 2 gets cancelled. So 1 minus y squared by 2 into 1 minus y. So this is the formula for E of x given y. That's all. The sum is done. Thank you.